Okay, welcome back, class. And so what we're going to do today is put in the definition of what a vertical stretch and shrinking is, or compression. And so I'm going to walk through this, and it's just the definition based on what I had done last time. Okay, so when we're talking about vertical stretching or shrinking, we're going to suppose, again, positive real number. Okay, we're saying if a point xy lies on the graph of f of x, then the point x comma a times y lies on the graph of a times f of x. Okay, so that's what we're saying. So that's true. Okay, so now given that that's true, if a is greater than 1, then the graph of a times f of x, so a is outside the function, we call that a vertical stretch, okay, of the original graph, right? Our basic, let's say our basic function, right? Our parent function, okay? If a is between 0 and 1, though, then the graph of a times f of x, again, we're multiplying outside the function, is called a vertical shrinking, okay, of the graph of the original basic or parent function. Okay, and so this is what we're using whenever we do a vertical stretch or vertical shrinking. So in other words, so here's the takeaway, just like I said before. If you're multiplying by a real number outside the function, that's going to result in a vertical stretch, is if the number is greater than 1. Okay, if the number is between 0 and 1, then that will result in a vertical shrinking, or what some textbooks call a compression. Okay, so that if you're outside the function, it's in the vertical direction, right? You're multiplying all the y's by some real number. If you're multiplying the y's by a number bigger than 1, then it's going to make the y's stretch. If you're multiplying by all the y values by some number that's less than 1, then you're making all the y values go down. Okay, that's what's happening in effect. Okay, that's it. Next time we'll talk about horizontal shrinking and stretching.